Welcome to Step on the Gas, turbocharging your analytics experience with Oracle Analytics. I'm Doug Ross, a manager architect with Performance Architects. I've worked with Oracle's BI and analytics tools since the late 1990s, starting with Oracle Discoverer, then moving to OBIE in the early 2000s. And now I work on projects implementing Oracle Analytics for Performance Architects. Performance Architects is an EPM, BI analytics, and data management consulting company. We are an Oracle Platinum partner and recently achieved Oracle's Cloud Platform Business Analytics Service Specialization, which requires having several consultants certified in analytics and data management. What makes Performance Architects different from other partners? In my view, it's our people. When we partner with you on a project, our goal is to be a trusted advisor based on our skills and our experience. We adapt to our customer's environment, not the other way around. Our people combine technical and functional expertise with a working style that focuses on communication and cooperation. The focus of today's presentation is Oracle Analytics. Recently recognized by Gartner as a visionary in the Magic Quadrant for analytics platforms, it is a true enterprise solution with the depth and breadth of capabilities to address the analytics requirements of any organization. Oracle Analytics accomplishes that goal by addressing three vital aspects of a complete analytics solution: governed, augmented, and self-service. So GAS, the driving force behind today's presentation. You can see some of the challenges here when implementing an analytics solution that isn't engineered for the enterprise. Dashboards that are nice to look at, but don't convey a lot of information. A cloud-only option that doesn't offer complementary on-premise solutions. Multiple versions of the truth depending on which analysts create an analysis, using their own calculations from sources that aren't verified. Shadow IT organizations that implement their analytics tool of choice at the expense of providing a unified solution. And data chaos driven by personal data dumps stored on local computers in unsecured data sets with inconsistent data. So let's step on the gas and learn more about the three core qualities of Oracle Analytics. Let's talk first about governed analytics. The focus here is on providing a managed platform that encompasses strong security and controlled corporate data models, combined with complete lifecycle capabilities to allow developers and data architects to build robust analytics applications that are accessed by a large population of data consumers. That means a true enterprise architecture, robust enterprise security, platform extensibility, an efficient developer experience, smart data connectors to a wide variety of sources, best practices metrics libraries, and pre-built analytics data models. What are some of the components of a governed analytics that make it critical to an organization? Number one, a single version of the truth accessible to all users. Common business names and metrics defined in a curated data model. Role-based security for data filtering and access to data elements that is applied automatically when a user executes a query. Rapid deployment of analytics instances using Oracle Cloud infrastructure. Reduced overhead for analytics environment administration by automating backups, patching, and scaling of services. Plus the strongest integration with Oracle SaaS applications to build real-time analyses accessing ERP and HCM solutions. Now let's take a look at governed analytics in action.
So let's take a look at a governed data model that exists in the Oracle Analytics Cloud environment. As you can see here, I have what's called a RPD, or a metadata repository, that's used to control access by users to a variety of different data sources. And the way that this RPD is set up, on the right-hand side, we have the physical layer, which provides our connections to a variety of data sources. And within those data sources, you may have different tables of different types that are joined together. In the center, we have what's called the business model and mapping layer, which takes the tables and column names that might be not very user-friendly and translates them into something that has business valid names that are available. So, for example, the fund table might have columns that have names that are mixed case that are more easy for users to understand. There also might be metrics that are defined at that logical layer. In this way, you can have a single definition of the truth for certain calculations that you want users to use. So, for example, on the account sum, we might have a variance column showing the fiscal year to date variance from budget to actual. And you can define a metric there that takes other columns and defines that calculation so that whenever a user brings it into an analysis or a project, that calculation will be applied. And then on the left-hand side here, we have the presentation layer. So this is how we take the logical layer and make it available to users in a variety of different formats. So for example, we can split out the general ledger and payroll into separate subject areas that are accessible by different users. And we can control access to those areas using permissions that are based on application roles that are defined. So only the users that have these specific roles assigned to their username would have access in the front-end tools. The other advantage we have here with the governed data model is the ability to do data filtering. So we can look at individual application roles that might be assigned to a user and apply various data filtering to those users. So in this case, a user who belongs to this facilities application role will only see data that is filtered by certain responsibility centers, 67 or an entity ID 06. So what will happen behind the scenes when a user who belongs to that role runs a query, the SQL that is generated will automatically have a where clause that includes those two conditions and filter the data transparently to the user. We can also use those roles in a governed model. For example, on the payroll table, we might have columns in the employee table that are restricted to certain employees. And if we look down here, there's a table called employee restricted. And there are columns in here like birth date that only users who have this specific application role for date of birth would be able to see that data. So that is the advantage of a governed model, is it gives an IT organization the ability to apply business rules and filtering all from one centralized location and be sure that the access to enterprise data is controlled and managed from one central source. So let's take a look at how these governed data models can be used in a real-world situation. In Oracle Analytics Cloud, as we've mentioned, it gives you the best of both worlds. It gives you governed analytics as well as the self-service. In terms of governed analytics, built upon a data model, you can create dashboards that are intended more for consumers to go in, more static data, more consistent dashboards that have a particular branding style that's consistent across an entire enterprise. So let's just take a look at one of these that's available. And this would be normally what you would see in the traditional OBIEE version of OAC. So if you're a current OBIE user, these are the types of dashboards you would build in that environment that are intended for users to come in, see something that might fit a business process requirement, and then have different drop-down values that are available in dashboard prompts where values can be selected and applied to pre-built analytics. So these would be anything that would be normally built by a developer or a super user, placed out on a dashboard and shared with users that allows multiple users to go in and access a consistent view of the data. And again, as I mentioned, the common theme here is having prompts on either the top or left-hand side, having multiple tabs that you can go to look at data, and having different visualizations on that. So the fact that the difference between self-service and governed analytics in terms of visualizations, that it's blurring as time goes by, that you can do more, the same types of things in both environments. The intent in the governed analytics side is to present something that, as I said, is more static, is more controlled, is distributed to a wider audience. And so, for example, for this fuel economy data, we have a different set of tiles up at the top, some bar charts, and a scatter chart all displayed on there. And we can pick a certain country if we just want to look at the manufacturers from the US. We can go down there and select that and click apply, and the data will be updated to reflect that.
Okay, time to put the pedal to the metal and continue our review of Oracle Analytics. Next, let's talk about an area that truly differentiates Oracle Analytics from its competitors, augmented analytics. This is accomplished by incorporating machine learning and AI across the full stack of the product line to power deeper insights into data. So that means intelligent search within data models and catalog objects, smart data discovery of insights, smart data preparation to help create quality data sets, natural language capabilities that transform visualizations into words and vice versa, and auto-suggest for ways to improve data and visualizations. So what are some of the components that make augmented analytics critical? There's built-in enhancements for data set ingestion. Oracle Analytics will suggest new columns to add to a data set based on profiling its contents as they are brought in. There's one-click explain function to derive insights into key drivers and attributes of metrics, generating useful visualizations automatically. Natural language generation visualizations turn charts into text that interprets the data to identify patterns, outliers, and trends. There's a simplified interface to generate visualizations from text and voice queries with built-in content search capability that produces visualizations as the user asks natural language questions. Let's take augmented analytics for a test drive.
So let's take a look at how we can use OAC's augmented analytics capabilities. Let's try bringing in a new data set from a file. This is fuel economy data brought in from a government website. And we're going to select this data set. And when it comes in, I'm presented with the different columns that are here. And I can change the properties of some of the columns. For example, it automatically recognizes columns that would be attributes versus metrics. So for things like the city miles per gallon, rather than do it as a sum, I want to show that as an average. And I'm going to do the same for the highway MPG. So we'll also do an average on that as well. So we can make other changes to columns, but when that's ready, here's where the augmented part comes in. I click on Add the Data Set, and now Oracle Analytics is profiling that data, looking at the columns, looking at the values that are in those columns, and then trying to determine where it might make some recommendations to add columns to your data set. So for example, we have a column out on the right-hand side called Release Date, and it's saying, well, you've got a specific date there. Would you also like to add, for example, the month of the year? So if we wanted to do a report based just on the month, and we can click on that. And since it's recognized that that is a date value, it's now added the month of the year to our data set. We can pick another column, for example, the transmission column. And if you look at the transmission column, you can see it has the words auto or manual. And it also has a value that's in parentheses after that. So what we can do is we can extract just the first part of that and add a new column. And it will be called transmission, and we can rename this. And we'll just call this, instead of the part 1, we'll call it transmission type. And hit that. And as you'll see on the left-hand side, OAC is building a script for processing your data. We'll click Apply the Script, and we'll save that. And now that it's done, we can create a project which would allow us to look at the data in visualizations. But the first thing we're going to look at is another advantage of using the augmented analytics. So I can right-click on City MPG, and you'll see down here at the bottom, it'll say Explain City MPG. What it's doing now is going out and looking at all the attributes that are related to the City MPG metric
and it's going to determine which ones are the key drivers of that value. And first, it's just going to bring you up a screen with basic facts about it. And then the key part here is key drivers. And now it's finding out that on CityMPG, the columns that are most useful for determining what that value is going to be are shown there. And it's creating a little bar chart for each one of those. So for example, we have number of gears, engine displacement, and the car line class. So we can pick the ones from these key drivers that we want by just checking those. And say add those selected ones to a project. And now we've got a dashboard that has these different values that we can start drilling into to find out more information about what these key drivers do. And if we go another level deeper, what are the factors that influence those as well? We aren't done yet. Time to accelerate into the next key area of Oracle Analytics. Self-service components of Oracle Analytics provide a complete end-to-end environment that far surpasses basic data visualization tools. It includes visualization and dashboarding, global transformation policies, experience continuity from mobile to cloud, smart collaboration between users who want to share insights, integrated data science functions, and KPI management to assess metric performance against a target. What are some of the components of self-service analytics that bring value to data analysts? Well, a consistent browser, desktop, and mobile user experience for building compelling data stories, adding forecast, clusters, outliers, and trend lines in a single click to a visualization, sophisticated but simple to use mapping capabilities that bring geospatial data analysis to all users, and extensible visualization options through add-ins that are available without cost from the Oracle Analytics library. Built-in machine learning to easily create prediction models without knowing other tools like R or Python. Powerful data ingestion options via data flows and sequences that allow for creating processes to cleanse and combine data rapidly. Time now for the final lap, where we will take self-service out on the test track. Let's take a look at some of the self-service capabilities of Oracle Analytics Cloud. I'm going to start with doing a demonstration of the data flows, which allows a user to transform data sets that have been brought in into cleansed, usable information that can be presented in projects. I do that by clicking on Create a Data Flow. And then I select a data set that we've brought in previously. And now in this case, I'm going to take this fuel economy data and join it with another data set that has some information about the manufacturers. And as you can see, it's automatically doing the joining between the two data sets on common attributes. And out at the right-hand side are the new columns that have brought in. Now, maybe I want to save this data set with just the US manufacturers. So I'm going to add a step and say I'm going to create a filter. Click to add the column that I want to filter on, manufacturer's name. And I'm going to only pick the US manufacturers in this case. And once I've done that, the data set is going to be filtered. I click on the next step, and now I need to save the results of this data. Give it a name. And change the aggregation on the data. So for the city MPG and highway MPG, we're going to change those to average. Save the data flow so that I can run it anytime in the future. And then run that data flow. And we get a data set that results. Let's quickly build a self-service visualization to choose a car that meets our parameters. So in this case, I'm going to select a manufacturer name, a transmission type, a number of cylinders, and create filters off that up at the top. Then I'm going to create an analysis that has the city MPG and the manufacturer name. And I'm going to just say create the best visualization off that. So we quickly get a bar chart that shows which ones have the highest city MPGs. I'm going to sort it from high to low. And then we're going to focus in on some of these. So I'm going to select some of the top 5, right click and say just keep those selected ones. And maybe now I'm going to drill in a little deeper and say on the cylinders, I only want a 4-cylinder car and a transmission type of automatic. So now we've limited this down to a certain number, and I'm going to duplicate this visualization, change the type, in this case to a table, and we can see the values there. I'm going to sort that from high to low, and then I'm going to add in the car line to this visualization, and we can see the sorted values for which cars meet that objective. Let's take a look at an actual storyboard built using the self-service visualizations in Oracle Analytics. Here I've created a narrated view of a number of canvases that were built very rapidly, and we're going to use that same fuel economy data, and we can move through the storyboard. Here's a scatter chart showing city miles per gallon and highway miles per gallon by manufacturers. And you'll notice that you have the ability to add notes that are tied directly to a data point. I've added outliers through one single click to this graph, and then we can look at those individually by highlighting them. On the next canvas, we're just showing different styles of presenting the data with bar charts that are placed in trellis views and a donut chart as well, all interactive to look at that data. The next canvas shows a tag cloud where the size of the words indicate the large values. So larger values have larger fonts. And this has been set up to use as a filter. So when I click on a value on the left side, it automatically filters the table on the right side. The next canvas is just showing a different style of a visualization. This is called a pictograph, where you can rapidly see different values according to the boxes that are shown there. Each box in this case represents 25 different models of cars manufactured in different countries. And then finally, let's take a look at the maps. And so in a mapping situation, we're looking at the number of cars manufactured in each country. And we can scroll in here and just take a closer look at in Europe, Sweden, Germany, different values as well. And again, this was able to be built very rapidly in a matter of minutes, and going from data to a storyboard that quickly using Oracle Analytics Cloud.
So there you have it. We've crossed the finish line. Performance architects can help you win the race to successful analytics implementation as well. We can provide guidance with a short-term proof of concept to get you started on your analytics journey, or help you migrate from on-premise OBIEE to Oracle Analytics Cloud or Oracle Analytics Server. Or we can assist you with integrating your Oracle Cloud ERP and HCM implementations with a world-class analytics platform. Are you ready to step on the gas? Thank you for your time today. If you have any questions, please feel free to contact me via email at dougross@performancearchitects.com. But now I'm excited to take any live questions from you in the Q&A.